right, 1.11. Here we go.
All right. Recall, let h of x equal f of x over g of x if g of c equals 0. If h of x has a vertical asymptote or pole at x.
All right, so when you get the denominator equaling 0, you either have a vertical asymptote or a hole. How do you get a vertical asymptote? A number over 0. How do you get a hole? 0 over 0. All right, so keep going.
Oh, example 1. Let h of x equal x squared minus 4 over x squared plus 7x plus 10. Write an equation for h of x in factored form and find any values of x squared. H of x has a hole or a vertical asymptote.
All right, fantastic. So we see quadratics. What are we going to do to them? F them up. Let's go. So what's the numerator f up to? X plus 2 and x minus 2. And what's my denominator f up to? X plus 2 and x plus 5. Love it. All right. And so what happens? Where do I get a hole at? X equals negative 2. I get a hole at x equals negative 2. Now, I want to go further. I want to figure out where that hole is actually. So we kind of cancel out these things, right? All right, so that's what creates the hole. And then I'm left with that simpler function. All right, I'm going to use this instead. So I'm going to substitute in negative 2. So let's figure out where my hole is actually located. So when I substitute in negative 2, what do I get up top? Negative 4 over 3. So I have what? Negative 4/3. All right, cool. And do I have any vertical asymptotes?
Yes.
Yes. What x value gives me a number over 0? X equals negative 5. Thank you for saying x equals, because it is a line. Negative 5 is a number. All right. All right, let's go to example 2 now.
Find the domain of h of x from example 1.
All right. So, real quick, in first period, they were having trouble for this for some reason. Domain is what you can substitute in, and the function doesn't break. And the function will break when the denominator is equal to 0. Okay? And so when the denominator is equal to 0, I either have vertical asymptote or a hole. So the domain is everything but my holes and vertical asymptotes. That's what the domain is. All right? It's when the denominator is not equal to 0. That's how we do that. All right? And so we have from negative infinity all the way till what? What comes first?
Negative 5.
Negative 5. And then it goes from negative 5 to negative 2. And then it goes from negative 2 all the way till infinity. All right? And so that is how we find our domain. It's everything, it's all the x values except for when my denominator is equal to 0 because it's undefined there. Good, El? All right. Example 3. Example 3. Now we have this quadratic over that cubic. All right? And so we're going to first write it in factored form. So let's F it up. Let's F up the top. What does it factor to? Go. X minus 4 and x plus 3. All right. And then what are we going to factor out of the denominator right away, though? An x. All right. And so then we're basically left with this x squared plus x minus 20, right? And so we're going to factor out the x squared plus x minus 20. And so what does that factor to? X plus 5 and x minus 4. Beautiful. All right. And so how do we find zeros of a function? When my numerator is equal to 0. All right, when my numerator is equal to 0. And so when is my numerator equal to 0, but it's not a whole? At negative 3. All right, and so I have a 0 at negative 3 comma 0. Now, where is there a hole? At x equals 4, right? And so this is at x equals 4, but I'm going to find the y value of it, so it's really 4 comma something. And so what is it in the numerator? 4 plus 3 is 7, and then 4 times 9 is how much? 36. So I really have a hole at 4 comma 736. All right. All right, does it have any vertical asymptotes? Yeah, how many has it got? It has 2 of them. Kyler, what are they?
X equals 0.
And?
X equals
Love that. All right. Does it have any horizontal asymptotes? Honestly, guys, when it says horizontal asymptotes, I usually look at the original. You can look at both, but I usually look at the original. And so, does it have any horizontal asymptotes?
Yes.
Yes. What are they?
Y equals 0.
Y equals 0. All right. And how did we know it was y equals 0?
Because the denominator.
Because my denominator had the higher power. All right. If they have the same z's power, what do we look at? The coefficient. If it's higher on the top, do you have any? No. Okay. You could have a slant asymptote, but it's not a horizontal asymptote. All right. So now let's find its domain. How do we find domain again? Everything but what? The zeros and not zeros. Sorry. Everything but what? Vertical asymptotes and holes. All right. And so now I'd go from negative infinity to what?
Negative 5.
-5. And then -5 to
0.
0. And then 0 to
-4.
+4. And then 4 to +infinity. Now, one thing that my students like when we talk about domain, how many times was it 0 in the denominator? How many times was it this time? 3. It was 3 times, right? And so if you have 3, you're going to have 4 intervals for your domain, because it's going to be one more every time. And so if you look at the first example, it's weird that it boxed it like that. That's strange. I don't know how I did that. All right. If you look at the first example, how many times was it 0 in the denominator? 2. So how many intervals did I have? I had 3. It's always going to be one more than. Okay. So sometimes that's a nice little check for yourself. All right. All right. So now we're going to start graphing it. But before we actually use our calculator, all right, we're going to substitute in what we know. So it has a 0 at -3, 0. So I'm going to put -3, 0 right there. It's going to have a 0 right there. And then it says it has a hole at 4, 7/36. All right, so at 4 and 7/36, somewhere around there, I have a hole. And then it says I have a vertical asymptote at x equals 0. And it also says I have a vertical asymptote at x equals -5. And then it says I have a horizontal asymptote at y equals 0. All right. And so now we're going to use our graphing calculator to figure out where they go. Now, before we actually do our graphing calculator, I want to go one more step. I have a hole going on right here. Remember, asymptotes get really close, but they don't touch? So is this actually going to hug up like this, or is it going to hug down? It's up here, so it's going to do what? It's going to hug up. All right, and so it's going to hug. Wow, that's weird. I have no idea how I did that. That's kind of fun, though. I'm going to keep it. All right, and so there's where it's going to hug there. So it shouldn't be a surprise. Let's get out our calculator and graph it. And so now when we graph it, we do notice that this thing is above. So we got this above right over here. And then this one's going to start there and then end up going down. And then this one is going to start hugging down. All right. And so there is our graph of that rational function. All right. All right, let's keep moving. All right, so on this one, we're going to have to do a little bit of thinking. So this one says, I have this graph. Now I have to find the equation. And this is a lot harder than a multiple choice part, okay? But we're going to basically kind of format it into a free response. All right, so what do we notice about this graph? There's multiple things that we're going to notice here. What do we notice? There's a hole. Where's there a hole at? We're going to write this out. Where's there a hole? At 4. And what is the hole at? 4 comma what? -1/2, right? So there's a hole at 4 comma -1/2. Cool. Anything else we notice? We should notice multiple other things. There's asymptotes. Where's my vertical asymptote? X equals 2. Awesome. And do we notice anything else? There's a horizontal asymptote. Where's there a horizontal asymptote? At y equals -1. All right, those are the things we should notice. And now we're going to start dealing with them. All right, and so I like to think of this horizontal asymptote first. I think that's the easiest one to work with. or sorry, the vertical asymptote of that one, I think that's the easiest to work with because what do I know is happening? What do I have on my denominator? X minus 2. Okay, that's the easiest one to work with is the vertical asymptote because I'm going to get a number over 0. I'm going to have that vertical asymptote going on. Make sense? Cool. Now, let's talk about the whole. What's going to create the whole? 0 over 0, right? And so what factors am I going to have on my numerator and denominator? X minus 4 on both of them, right? And so that's the easy part, okay? But now I need to have a whole at 4 comma negative 1/2, and I need to have a horizontal asymptote at y equals negative 1. And so this is where things are going to kind of be like a little bit of guess and check almost, all right? And so how do I get a horizontal asymptote at y equals negative 1? I need the same powers, don't I? All right, I need the same powers. Well, what's my power on my denominator? 2. So I have like an x squared in my denominator, yeah? And so what do I want on my numerator?
X squared.
Not just x squared, but a what? A negative x squared. I want a negative x squared up there. Does everybody follow me on this? All right? And so the way that we sometimes do that is we can tack on a negative, or we can maybe like flip something. All right? And so I'm just going to say it's going to be a negative up there. And then I'm going to try to deal with my whole part. All right? And so what canceled out on my whole? This x minus 4s, right? And so I'm going to substitute in 4 right here. Does everybody follow me on this? And so if I substitute in 4, what do I get?
2.
I get 2, right? And so if I were to substitute in 4 right here, I have to have an x right there. What am I going to add or subtract to 4? Because what do I want my whole to be at? I want my whole to be at negative 1/2, right? And so when I substitute in 4, I get 2 on the bottom. What do I need up top? A negative 1, right? And so what do I need to do with this? I'd have x minus or plus what? X minus 3. And so I really want x minus 3 right there. And again, why is it negative? Why is this one negative? Because what do I need to have? I need to have a horizontal asymptote at what? Y equals negative 1. All right. So this one creates my whole. I substitute in 4 to end up getting where my whole is at. That's going to get my vertical asymptote. And then my coefficients are going to give me my horizontal asymptote. All right. All right. Let's do another one. I think these are much easier when they're multiple choice than they are free response. Okay, and I would highly guess that these are going to be multiple choice, all right, on an actual exam. All right, so here we go. Let's do it again. So what do we notice about this equation, or this graph? A hole. Where is there a hole? At what? 2.5. At 2 comma 1/2. Love that. All right, what else do we notice? There's a vertical asymptote. There's actually 2 of them. What are my vertical asymptotes?
0.
X equals 0 and
X equals 3.
x equals 3. Love that. Do we notice anything else? It has a horizontal asymptote. Where's there a horizontal asymptote? At y equals 0. So let's break this down a little bit. All right, so let's start writing out g of x here. All right. And so what's my horizontal, or let's do my vertical asymptotes first. I like to start there. So what's going to be in my denominator?
X.
An x and a what?
X minus 3.
X minus 3. All right, love that. And what else is going to be in my denominator if I need to create a whole?
X minus 2.
X minus 2's. So I'm going to have an x minus 2's going on there. Everybody see how we did that? Now, would that actually create a horizontal asymptote at y equals 0? What creates a horizontal asymptote at y equals 0? The denominator has the higher power. So right now my denominator is x cubed, right? And then my numerator right now is just x. So my higher power is in my denominator, true? So we just need to make sure that that still happens. But it can be a squared over a cubed, right? And so let's see what happens. So this is going to totally create my vertical asymptotes. This is totally going to create my hole. However, I need to be worrisome about where my hole is located. And this says my hole is located where? At 1/2. Now, what we should also see on this one is that there is a 0. Where is there a 0 at? At 1. There's a 0 at 1. And so I have a 0 at 1 comma 0, or x equals 1, right? And so how did we get that? And x minus 1 in the numerator. And so would it still give me a horizontal asymptote at y equals 0? Yes, but let's make sure we get our hole where we need it. So again, on a hole, we cancel out this portion to make my simpler function. Where's my hole going to be located? At what? At 2. So let's make sure we get it. So if we substitute in 2 right here, what do we get? 2. What do we get here? -1. So what do I have in my denominator? -2. What do I have going on here? I got 2 minus 1, which is how much? 1. So what happened here? I'm off by a negative, aren't I? I'm off by a negative. So how can we just adjust that? Put a negative out. Now, this is what I would do to check it. All right? So do you see how we have like multiple vertical asymptotes going on? I would check it. So if I do a limit as x approaches 0 from, you want the right or the left? I really don't care. Right. Let's do right. So how do I actually want to think of this 0 from the right? A really small what? Positive. A really small positive. Does everybody follow me on this? So if I substitute in 0 right here, this is going to give me a what? Negative. This is going to give me a? This is a negative, right? So a negative, negative, negative is a what? Negative. So I have a negative over. Now, what's this going to give me? A negative. This is going to give me a negative. This is going to give me a really small what? Positive. So I have a positive, negative, negative, which makes it a really small positive. So a negative number over a really small positive is going to give me what? Negative infinity. All right? So if I go from 0 from the right, 0 from the right is right here. Okay? This is 0 and it's going to the right. And so what's it doing? It's going which way? Down to negative infinity. So that should be okay now. If it were going to positive infinity, I need to change something. All right? Because it needs to go down instead of up. And so that's where this negative sign might come into play on like switching something around. Okay? All right, let's keep moving. Here we go. All right, I need another good reader for slant asymptotes. Tim, you were the last reader, right? Pick somebody.
David.
Given a rational function, if the degree of the numerator is 1 greater than the degree of the denominator, then the rational function is a slant asymptote.
All right, so again, when do we get a slant asymptote?
If the degree of the numerator is 1.
1. Exactly 1. All right. Does anybody remember the other word for slant asymptote? Oblique. Oblique asymptote. I like to call it slant asymptote. However, some textbooks call it oblique, but I usually call it slant. All right. Keep going.
The function k of x equals x cubed minus 4x over x squared minus x minus 2 is equal to x.
Yep, that. Graphed above.
Graph above has a hole at x equals 2 and a vertical asymptote of x minus 1. X equals -1. The graph of k of x does not have a horizontal asymptote, but k of x does have a slant asymptote at y equals x plus 1.
All right, beautiful. So if you remember from our other lesson, and I didn't really assess it, but do you see how we looked at these higher powers? Okay, last time we looked at those higher powers. And then we talked about like it being parallel to something, right? You remember? And so it was parallel to these coefficients. All right? And so we'd have 1 over 1. And so I'm parallel to y equals x. However, this one went up 1. And the way to get this is we're going to have to use long division. All right? And so keep going. We're going to finish this up.
Since the degree of the numerator 3 is 1 greater than the degree of the denominator 2, we knew that k of x would have a slant asymptote. To find the equation of the slant asymptote, we would use long division.
All right, keep going.
Long division. If f of x and g of x are polynomials, then f of x over g of x equals g of x times q of x plus r of x, where q is a quotient, r is a remainder, and the degree of r is less than the degree of g.
Beautiful. All right, and so let's talk about long division. I absolutely love long division, and so here we go. So we just made up a number of 776 divided by 21, so let's do it. So we're going to have 676 divided by 21. All right, so does 21 go into 6? No. Does 21 go into 67? Yes. How many times? 3. So we're going to put a 3 right there. Then we're going to multiply 21 with 3. And 21 times 3 is what? 63. I'm going to say you're going to distribute a negative and then add straight down. All right, so we're going to distribute a negative and add straight down. So 67 plus negative 63 is what? 4. And then Snoop Dogg loves math, so we're going to drop it like it's hot right there. All right, and so then we need 21 into 46. So how many times does 21 go into 46? 2. And so we're going to put a 2 right there. And so now 2 times 21 is how much? 42. And then I'm going to distribute a negative and I'm going to add straight down. And so what do I get? 4. Now does 21 go into 4? No. And so back in the day, you were like, remainder 4. All right? Which is really, the quotient is 32, and the remainder is 4, but the answer is really 32 plus 4 over 21, or 32 and 4/21. All right? And so anyway, if we can do it with just pure numbers, we can do it now with polynomials. All right? And I absolutely love long division. All right? So we now have 2x plus 1. And I'm going to divide into 6x squared plus 7x plus 6. So how do I go from 2x to 6x squared? What times 2x gives me 6x squared? 3x. So that's why we put it over the 3x column. So we get 3x right there. And so now 3x times 2x is what? 6x squared. And then 3x times 1 is 3x. Now, the reason why I don't like to subtract is you guys mess it up too much. So I like to say you distribute a negative. So we're going to just change the sign. So we go pew, pew. And then we're going to add straight down. You make less mistakes this way. And so now, what happens to the x squareds? They go away. And so how many x's am I left with? 4x. And then, because I like Snoop Dogg, we drop it like it's hot. So now we have plus 6. All right, so now 2x to 4x. How do I go from 2x to 4x? What do I need to multiply by? 2. So now we have a plus 2 up there. And so now 2 times 2x is 4x. 2 times 1 is 2. And then what would I suggest you do? Distribute the negative. So we go pew, pew. And so then what are we left with? 4. And so now my quotient is 3x plus 2. My remainder is 4. And so my answer is 3x plus 2 plus 4 over 2x plus 1. All right? Just like what we did with our numbers. All right? And so now there's our polynomial. So before we go too far, the way that we did slant asymptotes, if I were to look at my function of 6x squared plus 7x plus 6 over 2x plus 1, right? Did I know that there was going to be a slant asymptote if that were the function? Yes, because why? It's one more. The degree is one more. All right. And all I knew before is that these coefficients had a slope that was going to be 3. However, my actual slant asymptote is y equals 3x plus 2. All right. That is actually my slant asymptote. It's everything but your remainder. All right. That's like noteworthy junk right there. All right. So on this one, we have this function. We're going to use long division to find an equation of this slant asymptote. All right. So let's put it into form. So now I have 2x plus 1. It looks very similar to the one we just did, but it's different. All right. So how do I get to 6x squared from a 2x? 3x. So I put a 3x right up there. And then what do I get? 6x squared plus 3x. What would I highly suggest you do? Boom, boom. You are more than welcome to use those noises. All right. And so then how many x's do we have? Negative 2 x's. And then we love Snoop Dogg, so we drop it like it's hot. And so then how do I get from 2x to negative 2x? Not 1, but negative 1. And so then I'd get what? Negative 2x and then plus 1. Or minus 1, thank you. Minus 1. And then what would I suggest you do? Boom, boom. And so then we get what? 6. All right. And so my technical answer is 3x minus 1 plus 6 over 2x plus 1. However, what is my slant asymptote? Y equals 3x minus 1. Now, to be completely honest, guys, I sometimes stop right here. Once I get this right here, I'm going to stop. Because do we actually need to keep going to find out what the true remainder is? No. Okay? Just trying to throw that in there. All right? I love long division. I might keep going just for funsies. However, you don't actually have to. All right, let's look at example 7 now. So I have this cubic over this quadratic. So, first of all, will this have a slant asymptote? Yes. All right, but we're going to keep going. We want to talk about vertical asymptotes, horizontal slants in its factored form. All right, so here we go. What can we factor out the top right away? An x. So let's factor out an x. And then I'd be left with like x squared plus 4x minus 12. What does that factor to? X what? Minus 2 and x plus 6. Love it. All over. Now, what is the bottom factor to? X plus 1, x plus 6. Love it. All right. So, do I have any vertical asymptotes? Yes. What? X equals negative 1. All right. Make sure you put x equals because it is a line. What's going on at negative 6, first of all? A hole. There's a hole. Now, this one doesn't necessarily ask for the hole. We're just going to talk about there is a hole at x equals negative 6. All right? Now, does it have a horizontal asymptote? No. Why not? It's a slant because my higher power is in my numerator. So it doesn't have a horizontal asymptote. Does it have a slant asymptote? Yes. How do we find that bad boy? We're going to long divide. Oh my gosh, I love this. All right, so now I have x squared plus 7x plus 6, and I'm going to divide into x cubed plus 4x squared minus 12x. Does anybody know what I should put next? Plus 0, because we actually need a placeholder. All right, guys, remember that from last year a little bit? So let's say I didn't have an x squared. This is a 4x squared, but let's say I went just x cubed and then minus 12x. I would still have a slant asymptote, but I'd have to put in like a 0x squared as a placeholder. All right? Remember those placeholders? Cool. Love it. All right, so how do I go from x squared to x cubed? X. So we're going to put an x right over the x column. And so then we get what? X cubed plus 7x squared plus 6x. What would I highly suggest you do?
Distribute a negative.
Pew, pew, pew. Then we add straight down. So how many x squareds do we have now? Negative 3x squared. And how many x's do we have? Negative 18x. Sheesh. And then we drop it like it's hot. So now we have plus 0. And so now, how do I go from x squared to negative 3x squared? Negative 3. Could we actually stop there? We could stop there. We could stop there. Because it's going to be a linear. So what do we know my slant asymptote is? Y equals x minus 3. All right. Pretty good? Could you keep going if you wanted to?
Yep.
Sure could, but we don't need to. All right, let's keep going on example 8 now. All right. Who was my last reader? Pick somebody.
Let d of x equal 2x times x plus 4 times x minus 1 over x squared minus 2x plus 1. Which of the following about the graph of d of x is correct?
I don't know.
Do I read those as well?
No. What should we do first to find out anything?
Factor.
We should factor that denominator. I agree. So let's factor it. So now we have 2x, x plus 4, x minus 1. And what does that denominator factor to? X minus 1, x minus 1. Love that. Cool. And so what do all these answer choices ask? About horizontal asymptotes, holes and vertical asymptotes, and slant asymptotes. It's going to ask about that stuff, right? What happens here? What do I got going on here? What can we cancel out? Anything? We can cancel out an x minus 1, right? But what'd that create? That created a vertical asymptote this time. Why is this one a vertical asymptote? Because there's still 1 in the bottom. All right, because if I substitute in 1, what do I still get? A number over 0. So this does have a what? Vertical asymptote. So for sure. Does this have a horizontal asymptote? No. Where's my higher power? Up top. And so what is my numerator? This is actually going to be like a 2x to the third, right? And so does it have a slant asymptote?
Yes.
Yes. Does it have any holes? No. It does not have any holes. So what am I trying to look for? It has a what? A slant and a vertical asymptote. And no horizontal and no holes. So which one says that? D. Do we see how we went through that? All right, cool. All right, example 9. All right, so let's read this one. So we're going to sketch its little graph, but the limit as x approaches infinity. So my inputs do what? My inputs increase without bound. And then what do my outputs do? Decrease with a bound. This one, my inputs do what? Decrease. And so what do my inputs do, or my outputs? Increase. All right, cool. What's happening at negative 1? This guy from the left goes to negative infinity. This guy from the right goes to negative infinity. What's happening at negative 1 then? It's a vertical asymptote. So let's draw it. So we're going to draw out our vertical asymptote at negative 1. And so the way we read this is x approaches negative 1 from the left. It goes to negative infinity. So when I approach negative 1 from the left, it's going down. It's going down. And then this one, I approach from the right. It's going which way? Down as well. All right, so that's all I know so far. Then let's talk about the end behavior now. So as I move right, which way am I going? I'm going down. So as I move to the right, I am going down. And what does this one say? As I move left, I go which way? I go up. Now, we don't actually know if this one has a slant asymptote or not. However, I bet it would. All right. So because you have them going in opposite directions, one's going up from the left and one's going down from the right, and you have a vertical asymptote, I would guess that you have a slant, but this one doesn't necessarily tell you that you have one. All right. All right.